Okay, so what we're going to look at here is the different types of graphs, the types of plots and table values that you might run into. And I know the instructions say here we're going to look at the mode, median, mean, and range. However, if we did all that for each of these examples, this would turn into an extremely long video. So instead, I just want to talk about how to kind of look at and read each of these tables, these graphs, and these plots. How to set up the number values, the list of values. That way you can determine the mean, median, mode, and range, which you have done after watching the previous video. Okay, so we're just going to look at how to kind of set up or list the values, and then of course using the video from last time you can go back and then find the mean, median, mode, and range. Okay, so like in this first example, and we'll do these examples in class together as well, it talks about sales tax. Okay, so it lists the different states like Oklahoma, New Jersey, Michigan, and so on, and then lists the sales tax in those different states. Okay, now sales tax, like when you go to Walmart and you have to pay tax on your groceries, that's the sales tax. Okay, so it says like Oklahoma has a 4.5% sales tax, New Jersey has 7%, but maybe places like in New Hampshire it's 0%. Okay, now this is just a table. Okay, so this is just a table. Okay, it's just a straight up table of values. There's nothing significant of this. This is similar to what we did in the last video. We can literally just list out from least to greatest the same values that we see, and then find the mean, median, mode, and range from there. So let's just list out the values here. Obviously, the smallest value would be 0, and I have 2 of those. And the next value I see is 4.5. Then after 4.5, I see 5.5. Then 6 and 6. And then 6.25. 6.5. And 7. Okay, so as far as the table goes, it's just listing a set of values. In a sense, it does have some comparison with it because you can kind of compare the different percentages of sales tax here, but it's similar to what we did before. Just list out the values from least to greatest, and then from there, just like we did in the last video, find the mean, median, mode, and range. Okay, so that's for a table. This next guy, what we call this guy, is called a dot plot. Okay, you might guess it's called a dot plot because we have dots. Okay, now the way this is listed out is they give you some kind of a number line like this guy here. In this case, they tell us the title of this is it's U.S. Senators when assuming office. Well, you might say, well, what do these numbers represent? Well, that's what they're labeling the axis here, which is age. Okay, so it's the age in which these U.S. senators are assuming office. So the way the dot plot works, it's very, very similar to what we're going to see later, like a bar graph. It's used to compare things, okay? Just like in this case, it's used to compare the different ages in which U.S. senators assumed office, okay? So if you see a dot there, that means one senator is at that age. If you see more than one dot, that represents one or excuse me, in this case, it could be 2 or more senators in that spot, okay? So this guy, there's one individual that was 42, one individual that was 46. The numbers in between here, this would be 47. Maybe I can zoom in and write that in. Notice it's going by 2, so this would be 47. So 2 people were 47, 1 was 50, 2 were 52, 1 was 55, 1 was 60, 1 was 61, and 1 was 62. Okay, so that's how we read a dot plot. Then, of course, what's really nice about a dot plot, it's already in least to greatest anyways. So when we list out the numbers, it'd be 42, 46 is the next one. Then notice there's 2 dots for 47. That means 2 different people. If I could write it out, 2 different people for 47. Then we have 1 dot at 50, 2 dots at 52, 1 dot at 55, 1 dot at 60, 61, and 62. Okay, so then again, after we list the set of numbers there, we can go ahead and find our mean, median, mode, and range, but that's how we want to be able to read a dot plot, which is comparing the different ages, in this case, of the U.S. senators. Okay. The next kind of plot that you might run into is called a stem and leaf plot, just like it lists here, a stem and leaf plot. Okay, now with a stem and leaf plot, the stem is usually the first part, the first digit that's going to be listed in the values, and the leaf lists all the values that follow after that first digit, okay? And what I mean by that is oftentimes they give you a key here. For instance, the stem is 1, the leaf is 8. When we put it together, we get 18, okay? So the first digit is 1, the second digit is an 8, so together that makes 18, okay? Now what this is useful for is it's another way to kind of list the frequency of a certain group of things occurring, okay? So if we wanted to kind of break things apart in terms of, in a sense, this would be like the ones category from 0 to 9, and then the 10s, the 20s, and the 30s, we can see the relative frequency of things occurring within those groups. Okay, so when we're given this value here, what this really means here is 0, 4. Now, how many of you write 4 as 0, 4? You don't, okay? So really what this means here is that this guy is just 4. So the first digit would be 4. The second digit would be 4. The next digit would be 4. 6, 8, and 9. So that would take care of the first stem and leaf because you're not going to list 0 in front of those numbers, okay? The next stem, though, is a 1 followed by a 0. Well, based on the key, if we put that together, a 1 and a 0 would make 10, okay? So the next value would be 10, and then a 1 and an 8 would make 18, okay? So that would take care of the tens place. Then the next group we're dealing with is the 20s. In this case, 28. Okay, a 2 and an 8 make 28. Then the next value would be the 30s. A 3 and a 4 make 34. And a 3 and an 8 make 38. Okay, so this would be our list of values. And then we can go through and find our mean, median, mode, and range, okay? So it's showing, in a sense, it kind of shows some relative frequency here. You can see that most individuals kind of fall into this category for Olympic medals that were won. So not a huge amount of people are winning like 34 and 38 over here. Let's see. Oh, yeah, the bar graphs, okay? So this is a bar graph. Okay, now you might notice, just because it's in the name, we have bars, okay? It has an x-axis and a y-axis, just like we're looking at a coordinate plane, but what this is used is to compare different things, okay? In this case, it's comparing a basketball tournament and the number of appearances these different teams make within the tournament. So Boston College, it looks like Marist, oh, I'm going to butcher these names. Let's find a name I can pronounce. Boston University, North Carolina, and so on, okay? So it's just comparing the number of appearances that these different colleges make in the basketball tournament. Now, what you need to be concerned with are the y-axis values, okay? That's the actual list of numbers we're concerned with. So, for instance, notice it's going by 2s. This would be right here, 18. That means this group, the Boston College, appeared 18 times. The next group appeared 2 times because this is going by 2, so this would be 2. Okay, then 12. And it looks like if this is halfway in between, if this is 6, halfway in between this would be a 5. Halfway in between there would be a 7. Okay. And then halfway in between 0 and 2 would be 1. At the top here, 44, going up by 2s, this would be 46. Okay, if we're going by 2s here, maybe I get rid of this line. This would be 46. And then it looks like we're at 18 again. We're at 10 here, 10. And then we're at 1 again. And then halfway in between 8 and 10 would be 9, okay? So we're concerned with those values, and that's what's going to help create our list here, okay? So then making this list here, our smallest value that I can see is a 1, but we have 2 of those, okay? Then the next value I see is a 2. The next value I see is a 5, 7, so 1, 1, 2, 5, 7, 9, 10, 12, 18, 18, and 46. I think I got it all. 1, 1, 2, 5, 7, 9, 10, 12, 18, 18, 46. Looks good. Okay, so then this would be our list of values here for the mean, median, mode, and range, in which we can determine what maybe the mean number of times or the average number of appearances a certain college would make at the basketball tournament. Okay, now a bar graph and a dot plot are similar because they compare things, and you can even see if you look at the dot plot, it kind of looks like a bar almost. Okay, they're used to compare different things. In our example, the first one was comparing the age of senators. This was comparing appearances at a basketball tournament. And then the stem and leaf plot is kind of more of a way to show relative frequency of things occurring within different groups. Okay, so more often than not, a lot of people were in this category. And then one of the next things we're going to look at is called a line graph. Okay, so a line graph. Now, a line graph, just like it says there, we have a line here. But a lot of the times, you'll see a line graph when you're trying to show changes over time. Okay, so notice it talks about cost of electricity. In this case, we have the x-axis is years, the y-axis is cost. So it's showing the cost over the years. Okay, how does that change over the years? Okay, so line graphs often show changes over time. Now, what we're concerned with, again, we're only concerned with these y values here, okay? Those guys are going to be the list of values that we want. So notice, again, they're going by twos. So this first value would be an 8. Halfway in between 8 and 10 would be 9, 9, 9, 9, 9. Then halfway in between 10 and 12 would be 11. Whoops. So this value over here is 11, 11, 12, and it looks like the next value would be 13. Okay? So the list of values, and it's nice that they kind of listed the line graph like this. It isn't always going to necessarily be like that, but we can literally list it in order from least greatest right there. So we have 8, 9, 9, 9, 9. Guess you can tell what the mode's going to be. 11, 11, 12, and 13. Okay? So then from this, we can find our mean, median, mode, and range, okay, for cost of electricity per kilowatt hours. Okay? Now, the last thing that you're going to see is a frequency table, okay, a frequency table. Now, with the frequency table, it's similar to the idea of the stem and leaf plot, but not exactly the same thing, but it has the same idea where you're listing the frequency of how many times a certain event occurred. Okay, so this is a frequency table. Okay, now the way you would read this is what it means is in a goals in a hockey game. For individuals that scored in the game, okay, so goals in a hockey game, those that scored 3 goals, the number of times that occurred was 3 times. So the number of times that 3 goals were scored was 3 times. The number of times 4 goals were scored was 2 times. The number of times 6 goals were scored is 1 time. And the number of goals in which 7 goals were scored is 4 times. So it shows you how many times these numbers occur. Okay, so the way we would look at that is there are 3 threes. So if we list our values, there'd be 3 threes. There would be 2 fours. Okay, there's 2 fours. There would be 1 6. Okay, so one event in which 6 goals were scored. And then there would be 4 sevens. So 7, 7, 7, 7. Okay, so this would give us our list of values there. That's how we want to read a frequency table. It lists the number of times that this number occurs. Okay, and then from there we can find our mean, median, mode, and range. Okay.